First, thank you for the organizer to give me this opportunity to give you some information about Tunisian olive oil and to give me the opportunity to present for you our research in our laboratory in such very nice area. We will talk about Tunisian olive oil, high added food value and health benefit. As you know, Mediterranean region is widely cultivated for the production of olive oil. It contains about 98% of the number of the olive tree in the world. North of Africa, olive farming is largely dominated by Tunisian olive grove with 70 million trees and more than 1.7 million hectares. Shimleli variety is dominant and represents 60% of total planted olive tree in Tunisia, especially in the south and center. Olive oil remained stable during the storage period. This due to the presence of phenolic compound with antioxidant activity which increase its life and protect its organoleptic quality. Olive leaves have also a long benefit from the medicinal reputation due to its potential source as natural phenolic compound and therapeutic interest. This, given the increasing use of plant extract as source of antioxidant nutritional supplement or even drugs, it is necessary to define their quality and identify their chemical composition. Let's go to present how olive is coming to Tunisia. The olive tree is rich in history of the Mediterranean region. The culture of olive oil goes 2 years. It was first brought to Tunisia from the Middle East by the ancient Phoenician founder of Carthage. Then, throughout the Mediterranean history, Carthaginian, Roman, Arab, and all civilizations have been passing the civilization known how from one generation to the other. This is some photo from our monument that show that olive is so long time in Carthage in Tunisia. And this is the olive tree. This one is the old one tree in Tunis is since 2,500 years from Carthage and they still produce olive. Tunisian olive category and orchard. There are 3 categories of olive orchard emerged then down by age bracket. Young orchard 17%, bearing orchard 58%, and all orchard 25%. Olive are found in all the regions of Tunisia, north, south, and center. They are cultivated with other crops such as cereal in the north, citrus, fruit, and wine, and cabon. And in the south, it is only monoculture for olive oil. Close to 90% cultivated olive average is located in center and south region. It means near deserts. The Tunisian olive cultivar heritage varietal is rich and diversified. Over 45 varieties until now is identified. Among them, we can mention Shimleli of Sfax, which is very famous. The surface used in Tunisia for olives is about 18.6%. It is in the second place of the world after Spain. When we compare the surface planted or for farming. Olive oil cover 1.8 million hectares. It's about the third of cultivated farmland. 180,000 tons of olive oil, 6% of the world production. In Tunisia, olive product and byproduct industry is represented by 1,750 units of olive oil extraction, 10 of pomace extraction factory, 13 edible oil refining units, and 24 packing units of olive oil. In Tunisia, the number of the persons who work totally in olive oil sector is more than 1 million. It is about 10% of the population. Here we see how the crop olive oil is gone, and some field in Tunisia. It is not a mountain like here. It's all flat. In Tunisia also we use all the byproduct of olive, such as fruit, olive table, olive leaves, olive wood, olive oil, and also we manage with olive meal wastewater. What is the composition of the olive? Sorry. It's about 98% of triglyceride, 2% of mineral compound, and this 2% is very interesting for the olive oil and for our health. And more than 230 identified compounds until now in olive oil. The slightly bitter and pungent taste is attributed to phenolic substance contained in olive oil. We can see the variety of phenolic compound in olive oil, such as flavonoid, lignin, saccharidoid, phenolic alcohol, and phenolic acids. This is structure of some compound found in olive oil, such as oleuropein, legistrosid, hydroxytyrosol, tyrosol, caffeic acid, and gallic acid. The taste of the major phenolic in olive oil may come from oleuropein aglycone is a bitter, legistrosid aglycone pungent, and oleocanthal. It can give the sample phenolic compound such as hydroxytyrosol, tyrosol. The main reaction when we extract olive oil are here. We can hydrolyze, we obtain hydroxytyrosol, which is a very high antioxidant compound, and we can obtain tyrosol with a weak antioxidant activity, in addition to linoleic acid. Here we present the mechanism of hydroxytyrosol to stabilize olive oil, which is the main compound. In addition, we have other compounds such as volatile compound. It contains hydrocarbon, aldehyde, alcohol, ester, and alkane. Now we will begin to present you some of our research in our laboratory about olive oil. We begin with the effect of procession system on the quality and the stability of Shimleli olive oil. As you know, there is two systems, very famous system, three-phase and two-phase. The difference is between them is about adding the water. In the three system, obtain pomace, vegetable water, and oil. However, for the two system, obtain pasta and oil. Now, because we have two systems, we obtain the pasta. Sometimes the pasta, it contains some oil. We do the extraction again, and we will see what is the composition and what is the stability of this oil. It means the pasta obtained after the two-phase, we do an extraction again. We add water and we do extraction to obtain it more oil. The phenolic composition of this oil shows that its name is rapacid oil. The rapacid oil contains a low quantity of phenolic compound compared to two-phase and three-phase oil. The decrease of phenolic compound in three-phase and the rapacid oil was due to the dilution of the olive pasta prior to the second centrifugation by the three-phase decanter, known to cause the loss of part of hydrophilic component. We have identified and quantified all the compound in the three oils. We find that oleocanthal and oleuropein aglycone is the main compound of the oil. But rapacid oil, it contains few compounds. Sometimes it not past 1 milligram. The two-phase centrifuge provide the highest transfer rate of phenol to oil compared to three-phase oil and rapacid oil, where most of the phenol were flushed away with the wastewater produced. For the volatile compound, a large quantity of semi-quantitative difference in volatile fraction profile between olive oil from two-phase and three-phase oil compared to the repasted oil may be attributed to the second centrifugation of olive pasta, so it is the second knitting step. Sorry. Volatile compounds contain a major compound such as aldehyde followed by alcohol, where the main chemical class detected in analyzed oil. Two-phase and three-phase showed the highest percentage of aldehyde and alcohol compared to the repasted oil. The major component of the volatile fraction of extra virgin olive were the C6 aldehyde and alcohol, which derive from cascade of enzymatic reactions starting with the formation of lipoxygenase action LOX pathway occurring during crushing of olive fruit and the malaxation of pasta. Now we compare by compound. 2-hexanal originated by oxidation of linoleic acid operated by lipoxygenase, and hexanal derived from the oxidation of linoleic acid were the most abundant volatile aldehyde in two-phase, three-phase, and repasted oil. 2-hexanal derived by linoleic acid oxidation and responsible of a green fruit note was the more abundant alcohol in two-phase oil compared to the three-phase oil and repasted oil. Alpha-farnesene, the tetrasaturated alcyclic sesquiterpene detected in the all oil, was more abundant sesquiterpene in two-phase than three-phase and repasted oil. For the sensory evaluation, we see that Shimleli Sfax olive oil from the two-phase and three-phase centrifuge show an intense fruity flavor, well balanced, bitter and pungent taste with the medium of defect equal to 0. However, for the repasted oil, we can detect negative attribute rancid and other registered for the repasted oil, classified this oil in lower category order following the detection of an organoleptic defect. The negative attribute rancid and other registered for the repasted oil confirm that this oil leads to oxidation during second centrifugation of the olive pasta and contact with air, and can be explained by the presence of several long chain aldehyde. Now, we have tried to get the maximum olive oil from the pasta. We have optimized the malaxation operating condition using carbonate calcium as a coadjuvant for efficient yield production and high quality parameter of Shimleli olive oil. To meet the growing need of consumer and to produce a high quality of olive oil, the development of extraction is extremely required. In fact, the effective olive pasta malaxation is crucial in producing extra virgin olive oil of an exceptional quality. It is important to extract the optimum amount of olive oil with the right quantity of antioxidant and best possible flavor. This compromise is linked to the variation of a lot of parameters. The methodology was to optimize the effect of the combination of three malaxation parameters: temperature, time, and the coadjuvant, to obtain the best and the high quantity of olive oil. We draw the quadratic response surface from the mathematical model in order to ensure the best quality of the resulting oil. The adjuvant exerts a quadratic effect on oil yield. The best result of the oil yield were obtained by using 1.25% of coadjuvant when the malaxation was at 35 degrees during 30 minutes. There is an improvement also in pigment content after adding CA/CA3 addition. This may be related to the capacity of this coadjuvant to facilitate the solubility of the pigment in olive oil. No significant difference was found when comparing olive oil before adding and after adding the coadjuvant for fatty acid and steroids. After this study, we can tell that the optimal condition for malaxation optimization were temperature 31 degree, time 20 minutes, the coadjuvant not more than 1.6%. From this result, there was an improvement in olive oil yield up to 2% without negatively affecting its quality parameter. In addition, no significant variation was detected for fatty acid and steroid composition. Finally, oil could be classified as an extra virgin olive oil. Another study, olive quality from the whole fruit. We have divided the fruit in the pulp, seeds, and we have compared it with the fruit. The objective of this part is to see the effect of different parts of olive on the quality of olive oil during maturation. And the second one, effect of olive cultivar and the climate condition on the quality of the olive oil. The material, we have choose 4 varieties, which is named Shimleli, Zarazi, Nabijmal, and Dousleti. They are very known in the south. This is the map of Tunisia. You can see Sfax is here, where I come from, and the samples were taken from all over. This is the south. Here is the desert. We have measured the quality and the acidity. We see that seeds oil have the higher acidity compared to the fruit, all the fruit and pulp. Peroxide value also. It means the seeds oil is very oxidized, easily oxidized. From this, we can tell that the high acidity of the seeds may be explained by the presence of lipase activity, which hydrolyzes the triglycerol. And fatty acid and peroxide value did not exceed the maximum limit established by the International Olive Council for the extra virgin olive oil category. Now we go to the analysis of fatty acids and squalene from all the part of the olive fruit, pulp, all the fruit and seeds. We see that in whole fruit and pulp we have the higher maximum of oleic acid. Palmitic and linoleic acid are the major saturated and polyunsaturated fatty acid found in olive oil. The percentage do not exceed 20% for all samples and pulp and fruit oil, whereas seeds are characterized by a low percentage of palmitic acid and high content of linoleic acid, which exceeded 22%. Squalene, which is the it is very known compound with antioxidant activity and can stabilize olive oil. We can find, for example, in the cultivar of Dousleti, which is higher, it reaches 5 grams, 0.8 milligrams per kilograms of oil. We have the chemometric analysis. The first group was composed by Dousleti fruit and pulp oil. The second was characterized by Shimleli variety, whole fruit and pulp oil. And finally, the third group was made up 4 samples, Shimleli and Dousleti seeds oil. This was confirmed by hierarchical cluster analysis. For the phenolic compound, in all the variety studied, you find all European glycol and Oleocanthal was the major compound. The same for volatile compound, the majority was hexanal and developed aroma of green or fresh in olive oil. In fact, it represents about 60% of total volatile fraction, and it produced by the degradation of polysaturated fatty acid. For the sensory analysis, we find a very good attribute for all the olive oil. It reaches 4.8, for example, for the bitter and fruity. We have measured also for all the variety the stability oxidative of the oil using Grand-Cimat. We find that oil which is come from fruit, it is more stable than pulp, than seeds. It means the seeds is very soon oxidized. We have used also NMR and infrared to characterize the oil. The NMR analysis allowed the quantification of phenolic compounds such as oleocanthal, olecine, oleuropenaglycol, and ligustrizide. These two compounds is very interesting in medicinal field. These two compounds are identified for the first time in Tunisia. The oleocanthal and the olecine content was high in olive oil of Tunisia when compared to the value obtained in previous study of Greek and Californian oil. Using NMR, we can identify this compound. We use it also infrared spectroscopic to control the adulteration and the detection of fraud in Tunisian olive oil. This, it is 4-band characteristic of virgin olive oil. Our oil sample, this spectral data allow us to confirm that the studied oil belongs to category of extra virgin olive oil. In addition, we have a new method to confirm the authenticity of the olive oil. It means where it comes from and which cultivar. We have a graphical radial plot which is named morphogram, characterization the variety origin made with Excel 2003 was released. This representation was based on the difference between fatty acid data compared to the average of the same variable obtained from the same database, built with 2,900 samples from various source grouped by variety. You can see here that this is the form of Shimleli. If you give me a sample and I will analyze and I will put your sample on this, if it is not the same, it means it's not Shimleli, it's another variety. It's the same with other. This is our examples. Finally, I will show you some photo from my homeland. This is fish market, a big fish market. This is the government. This is the field of olive oil, and this is the city center. Sfax. We hope to see you one day there.